What if the products you use every day aren't breaking by accident, but exactly the way they were designed to? At some point, almost everyone has noticed the same strange pattern. A charging cable works perfectly fine for months, sometimes even a year, and then one day it starts failing in a very specific place. Not the middle, not the plug itself. Always the same small section near the connector, where the cable bends most often. It's easy to assume this is just normal wear, that you were careless or rough with it. But that explanation falls apart once you realize how consistent the failure is across brands, models, and users. Years ago, cables were built with thick reinforcement at stress points, designed to limit bending and protect the wires inside. That design still exists. The materials still exist. The engineering knowledge never disappeared. What changed was the incentive. Strong strain relief makes cables last too long, and products that last too long don't get replaced often. By shortening and weakening that protective section, manufacturers can turn a durable accessory into a consumable. The difference in cost is minimal, but the difference in replacement frequency is enormous. A cable that could survive years of daily use now becomes something you expect to replace regularly, and over time, that expectation feels normal. The same logic shows up even more clearly in home printers. Printing something important should be simple, yet printers have become infamous for refusing to cooperate at the worst possible moment. A message appears claiming the ink is empty, even when you know it was recently replaced. The frustrating truth is that many cartridges still contain usable ink when they stop working. Inside the cartridge is a chip that tracks usage, not actual ink levels. Once it decides the cartridge has reached its limit, it tells the printer to stop, regardless of what's physically left inside. Refilling the cartridge doesn't always help, because the chip continues to report it as empty. This turns ink into one of the most overpriced liquids consumers regularly buy, often costing far more per gallon than luxury items. The printer itself is often sold at a low price, sometimes even below cost, because it isn't the real product. The ink is. The business model depends on locking users into proprietary cartridges, firmware updates that block third-party replacements, and systems that prevent basic workarounds. What looks like convenience on the surface is actually control, carefully built into both hardware and software. Wireless headphones offer another example, one that feels modern and sleek until time catches up. Traditional wired headphones had a simple relationship with failure. If the cable broke, it could be replaced. If a driver failed, the headphones stopped working, but that usually happened after years of use. Wireless headphones introduced a new weak point: sealed batteries. These batteries degrade predictably over time. After a few hundred charging cycles, their capacity drops sharply. That isn't a flaw, it's basic chemistry. The problem isn't that batteries age, it's that they're permanently sealed inside devices that are otherwise perfectly functional. When the battery reaches the end of its life, the entire product becomes unusable. Replacing the battery is often impossible without destroying the device. This transforms headphones into disposable electronics with a built-in expiration date. What makes this especially frustrating is the contrast between marketing and reality. Many companies promote sustainability and environmental responsibility while selling products designed to be thrown away after a few years. The technology to make batteries replaceable is not complicated. It's a design choice, not a limitation. Mattresses take this pattern into the bedroom, quietly affecting health instead of convenience. Older mattresses were built to last decades, using dense materials that resisted long-term compression. Modern mattresses often begin to sag shortly after their warranty period ends. This isn't accidental. Layers of cheaper foam are placed exactly where the body applies the most pressure. Over time, those layers compress, creating dips that may not qualify for warranty replacement but are enough to disrupt spinal alignment. Warranties are written with precise measurements that protect the manufacturer, not the sleeper. By the time a mattress fails officially, it has often been failing functionally for months or years. The result is chronic discomfort, back pain, and fatigue, all solved by buying another expensive mattress. The cost savings from using cheaper materials are relatively small, but the payoff comes from repeat purchases. A product that once lasted a generation now lasts just long enough to feel acceptable. What connects all of these examples isn't poor craftsmanship or accidental oversight, it's predictability. Each product fails in a way that nudges the consumer toward replacement rather than repair. The failure isn't random, and it isn't catastrophic. It's just inconvenient enough to make buying something new feel easier than fighting the system. Over time, this reshapes expectations. People stop asking why things break so often and start assuming that's just how modern products are. Repair becomes unusual. Longevity becomes a luxury. And the idea of owning something outright slowly fades into the background. This isn't about nostalgia for the past or resisting new technology. It's about understanding how incentives shape design. When profit depends on frequent replacement, products will be designed to wear out gracefully rather than last stubbornly. The result is a world where convenience comes bundled with fragility, and where control is disguised as simplicity. Once you notice the pattern, it becomes difficult to ignore. The broken cable, the useless cartridge, the dead headphones, the sagging mattress, they aren't isolated frustrations. They're symptoms of the same underlying strategy, quietly built into the objects people rely on every day. One of the clearest signs that something is wrong with modern product design is how often failure shows up where it shouldn't. A refrigerator, for example, is one of the simplest machines in most homes. Strip away the extras, and it's little more than an insulated box with a compressor and a cooling loop. This technology has been stable for generations. When built with durability in mind, it can easily run for 20 or even 30 years. And many older refrigerators did exactly that. Yet, modern refrigerators often start causing serious problems far earlier, and almost every time, the failure traces back to the same feature that was supposed to make life easier: the ice maker. The ice maker is a mechanical and electronic nightmare, hiding inside an otherwise robust system. It combines motors, sensors, heating elements, valves, and moving parts, all placed in an environment that constantly cycles between freezing cold and moisture. Ice forms, melts, refreezes, and melts again. Water expands. Plastic contracts. Metal fatigues. Electronics corrode. None of this is mysterious. Engineers know exactly how hostile this environment is, which is why it's impossible to argue that repeated ice maker failure is unexpected. It's expected. And when it fails, the repair cost is often so high that it reframes the entire appliance as disposable. People look at a $500 repair on an $800 refrigerator and make the only decision that seems rational: replacement. Meanwhile, the original solution never failed. Ice trays cost almost nothing, last forever, and require no maintenance. Convenience didn't replace them because they were bad. It replaced them because convenience is easier to monetize when it breaks. That same logic applies to countless appliances that appear solid on the outside, but rely on tiny, fragile components inside. These parts are not random weak points. They are chosen weak points. A latch, a hinge, a gear, a clip, often made from thin plastic, designed to flex just enough to work, but not enough to last indefinitely. When these parts fail, the rest of the machine is usually fine. The motor still runs, the electronics still function, but the device becomes unusable anyway. And instead of being able to replace that one cheap piece, consumers are forced into replacing large assemblies or entire units. The part itself might cost cents to manufacture, but it becomes the gatekeeper that determines the lifespan of a product worth hundreds of dollars. Strengthening these components would barely affect production cost, but it would dramatically reduce replacement frequency. So they remain weak, quietly doing the work of planned failure while everything else pretends to be durable. Cordless power tools reveal how this strategy evolves when companies move from individual products to ecosystems. Modern power tools are impressive. They are powerful, precise, and capable of doing professional-level work. Yet, their usefulness depends almost entirely on one thing: the battery. And batteries are where control enters the picture. Each major manufacturer designs batteries that only work with their own tools. The shapes are different, the connectors are different, the communication protocols are different. Over time, every rechargeable battery degrades. Capacity drops. Runtime shortens. That's chemistry, not conspiracy. But what happens next is a choice. Replacement batteries are priced so high that buying a new tool bundle often feels like the better deal. And when you choose that option, you don't just replace a battery, you deepen your commitment to that brand's ecosystem. Some companies go further, embedding chips that prevent tools from functioning with unofficial batteries at all. This is digital control applied to physical tools. The idea of universal batteries isn't technically difficult, it's economically inconvenient. Compatibility reduces dependency, and dependency is profitable. Washing machines show what happens when repairability itself becomes the target. Older machines were designed around the assumption that they would be repaired. Components were accessible, bearings could be replaced, parts were standardized. When something wore out, it was fixed, and the machine kept running. Modern machines increasingly abandon that philosophy. Critical components are sealed, welded, or permanently integrated. A bearing failure, once a minor repair, now requires replacing an entire drum assembly. That replacement often costs most of what a new machine costs. The message is clear, even if it's never spoken aloud. Repair is no longer the expected outcome. Replacement is. The decline in appliance lifespan isn't because engineers forgot how to build durable machines. It's because durability interferes with predictable sales cycles. When repair becomes economically irrational, disposal becomes routine. Phones represent the most intimate version of this pattern because people interact with them constantly. Unlike appliances, phones rarely fail in dramatic ways. They don't suddenly stop working. Instead, they slow down. Animations lag. Apps hesitate. Battery life shrinks. Performance degrades gradually, often following software updates. Sometimes this is framed as optimization, sometimes as protection, sometimes as necessary progress, but the effect is consistent. A device that once felt smooth and responsive becomes frustrating to use. And frustration is the most powerful upgrade motivator there is. By the time consumers start seriously considering replacement, the new models are already being advertised as solutions to problems that didn't exist when the device was new. The phone still works, it just doesn't feel good to use anymore, and that difference matters. What ties all of these examples together is not incompetence or coincidence, it's predictability. Failures happen in ways that are measurable, repeatable, and economically convenient. Stress points are known, lifespans are modeled, warranty limits are calculated. Software support timelines are planned. None of this is accidental. Products are designed not to fail catastrophically, but to decline gracefully. Just enough to push consumers toward replacement without triggering outrage. Just enough to feel inconvenient rather than broken. Over time, this changes how people think. Longevity stops being the default expectation. Replacement becomes normal. Repair becomes unusual. Ownership starts to feel temporary, even when the price suggests permanence. The most unsettling part is how invisible this process is. Each failure feels isolated, a broken latch here, a dead battery there, a slow update, a costly repair quote. Taken individually, they feel like bad luck. Taken together, they form a system where waste is normalized, control is hidden behind convenience, and choice is quietly narrowed. Consumers are told they are benefiting from innovation, while being trained to accept fragility as progress. And this raises questions that don't have easy answers. If a product is designed to fail in predictable ways, is that deception or just business? If repair is intentionally made difficult, where does ownership end? At what point does inconvenience become coercion? And perhaps most importantly, how much of what we accept as normal is actually designed to keep us replacing instead of owning? This series doesn't end with these examples. In the next parts, we'll go deeper into how these systems are built, how laws and regulations either challenge or enable them, and what happens when consumers push back. Some industries are already being forced to change. Others are doubling down. The patterns don't stop with appliances and electronics. They extend into software, services, and even the idea of access itself. If you've ever felt that things don't last the way they used to, or wondered why fixing something feels harder than it should be, you're not imagining it. And this is only the beginning.